I'm going to talk about the use of EuroForMix to analyse a sample that was used in an ENFSI exercise. It's a major-minor profile where the minor profile is evidential, and these are typically the most difficult cases to analyse. First of all, EuroForMix is designed to offer different functionality and methods of analysis for specialist applications, and we found that this could be confusing to users who are new to the method. So for routine casework analysis, we recommend that you use the easy mode, since this will automatically direct you towards the method that we recommend, and I'll demonstrate that in a moment. First of all, let's have the circumstances of the case provided. A man was stabbed in Madrid. The biological remains under the nails of the victim were collected during autopsy, and after the DNA analysis, a mixture was detected in the sample. The judge wants to know if the suspect contributed to the mixture. Reference samples from both the victim and the suspects are available for analysis. Well, let's load EFM. We should have an icon on our desktop, which I'll click on here, and then R will load, and then shortly after that the EFM template will load up. And here it is. The next thing I'm going to do is to load the project. And using this method very quickly loads your data, so you don't have to repeatedly analyze all the various parts of it individually. So here we have the kit, it's identifier, and it's a Spanish population. I've imported the evidence here, which I'll click on, and the reference samples from the suspect and the victim here. So now if I want to view the evidence, let's just click on here, and you can see all of the alleles highlighted here, along with the peak heights here. Here is the EPG here, and from the labels, the suspect labelled 1 and the victim is labelled 2. So here, for example, this corresponds to an allele found in the reference sample of the suspect, and we can very quickly see that this is a major mixture where the minor component appears to be evidential. And also, if we look through the profile, it's quite a simple profile, no more than 4 alleles, and that indicates that it is a 2-person mixture. Now underneath this EPG, let's just get rid of it, we get this graphical representation of the peak height summaries, and what this does is it tells us whether we may suspect there is degradation present. And as you can see, this line is a classic ski slope line, and so that the lower molecular weight fragments are amplified better than the higher molecular weight fragments. So this does indeed indicate that we may have degradation present. So the next thing I do, if we go back to this GUI, we first of all, let's just check the settings. Now this is the easy mode, which we click on here. We want to use that, and here the default detection threshold, the FSTs, and the drop-in parameters have all been loaded up. The drop-in parameter can be set from your laboratory data, as can the default probability of drop-in, of course. and we recommend that you measure these parameters in your own laboratory and fill them in. But if you haven't done that, as a default, you can use 0.05 as the default probability of drop-in, and for this parameter here, the drop-in parameter, we will set that to 0.01. We'll have a different lecture on how to set these various probabilities. Okay, so we'll just make sure that we save that. So using the easy mode ensures that a lot of these buttons here are greyed out. You can't use them. And we're doing this because we want to direct you down a route, a fail-safe route, so that you can't make any mistakes. So once you've loaded the data here, what you do is click on the weight of evidence, and then you get this GUI appearing. And what you do with this is you specify the model. So all of the loci that you want to use are clicked on here. If you don't want to use any of the loci, you can click them off if you want to. And here we specify the model. And with this particular model, we're going to look at, under the prosecution hypothesis, we have the suspect and the victim, and we think it's a two-person mixture. So we're going to set that to 0. And we want to condition on the victim, and that gives us one unknown contributor. We are allowed to condition on the victim because we've taken a swab from underneath fingernails of the victim, so we expect to see her DNA present. And then once we're happy with the model specification, we simply click on this, and that gives us the model fit here. So here we have got the estimates under the defence hypothesis compared with the estimates under the prosecution hypothesis. Here we have the mixture proportions under HP, and as we can see, the minor component is around about 26%, and the victim component is about 74% here. Under the defence hypothesis, we have very similar proportions. They're not in the same order here because under the defence hypothesis we don't distinguish between contributors. If you specify the suspect and the victim first, then they will appear in that order under the prosecution hypothesis. So the likelihood ratio is coming out here, 10 to the 15. And the parameter that we need to take notice of is this one. It's minus 338.8. And this parameter is used to tell you whether the model is a good fit or not. And I'll be covering that in part 2 of the lecture. Another thing we have to do, we have to think about the model validation. So I'll just click on this to show you how that works. Now the model validation is a PP plot between the fitted model and the theoretical model, and what we expect to see from this is a straight line. Of course, we never get a perfect straight line, so our definition of a straight line has to make sure that the plots are within this red line here, which is the Bonferroni correction of a 0.05 pp plot. So the points have to be within this envelope here in order for it to be valid. We can also look at the plot under the prosecution hypothesis just by pressing this one, and again this shows us that the model is perfectly okay. Now the actual likelihood ratio that is reported will come from this plot where we carry out a sensitivity analysis. So the MLE based plot gives us a log 10 likelihood ratio of 14.3, but we use the 5 percentile, which is here, and that is 14.3.